Welcome to this tutorial on how to set up a new conveyor using Build Analyst. In this example, in this tutorial, we will be starting a brand new conveyor and going through the basics of how to initially set things up on a very simple and straightforward conveyor. We'll start with the basics in this example, where we'll go ahead and click New Conveyor, or New for a new conveyor. It'll pop up with templates that we have preloaded into the program. You can create your own templates if you have a consistent design you typically use on all your conveyors. But for us, we'll just start with the simplest horizontal conveyor, head drive, head take up, and we'll make alterations to our design from there, understanding what we have. So once I hit OK, it'll ask me, where do I want to save this conveyor? I'm going to just hit, I want to save it as the default in this example folder that I have. I already have a file that exists, but I want to replace it, so I'm yes. And then it will also ask me, do you want to save the conveyor in the new file format? This is due to the fact that we have pre-existing versions of Build Analyst, and we want to know if we want this file itself to work with previous versions of Build Analyst, or are we okay with just the latest and greatest version working with this file. So I'm going to hit yes and allow it to work in the newest file version. So if you look at this window, looking on the right-hand side of the screen, we have kind of the basic setup of all our conveyors. We have the cross-sectional area, how our idlers would look with the load on it, the current profile, whatever we have input for our geometry of our conveyor, the basics like width, speed, load, and the ambient temperature, the lowest ambient temperature you see, as well as kind of an overview of our tensions on the bottom there. And that kind of gives you a summary of what happens on this conveyor, how it's being designed. On the left-hand side of the screen, we have tabs, and each one of these tabs will define important components of our conveyor. Starting with material, what sort of material are we carrying on this conveyor? Flights, this will define our geometry. Belting, this will define what belt we use on our conveyor. Idlers, drives, how big are our motors, drive system, take up, pulleys, and vertical curves if we have any. In this case, we don't have any on this conveyor. And then also an estimation of the trajectory of the material off the end of the head pulley for chute designing and those sorts of things. So let's, once again, like I said, we'll start from scratch, and we're going to go ahead, and the way we do things typically is to set up the right-hand side of the screen first, the basics, and then move down each of these tabs from the top to the bottom as we design our conveyor. And since we're starting up a new conveyor, you have to ask yourself, well, what sort of conveyor am I doing? Are you doing a pre-existing conveyor where you know the things on the right-hand side of the screen, or are you trying to model them to fit a specific need you have? In this case, we're going to pretend like we've been given an existing conveyor and the specifics are already known. And for that, we're going to set up the basics of the belt width, the speed, and the load based off of pre-existing knowledge as if this were an existing conveyor. We're going to say we have a 36-inch belt width conveyor running at 450 tons per hour, and our load is 450 feet per minute. Our load is 800 tons per hour. Once you set that up, you can see as you hit enter after every one of these inputs, the program automatically updates and recalculates based off of what you've input, how that changed the rest of the componentry, rest of the design of the conveyor, and if anything went wrong. So we're set there. I'm also going to say that our lowest temperature is 32 degrees, be less conservative than otherwise. So let's go. Let's start from the top and work our way down.